Delivering images at full size may not always be ideal, as displaying large images can lead to longer loading times and increased bandwidth usage. Whether we want to just resize an image or crop it to a specific aspect ratio, with Cloudinary's Python SDK, we can manage transformations efficiently. Let's first take a look at a full-size image. Assuming you've got Cloudinary installed and configured already, import and use the Cloudinary image method to pass the image's public ID, in this case moving day, and get back its deliver URL. Add the format equals auto and quality equals auto parameters to generate a URL that ensures the image is delivered in the best format for the requesting browser and at the highest compression level that maintains visual quality. Now we can open an HTML page that displays the image URL we just generated. Now I used HTML to resize the displayed image, but if you hover over the image in DevTools, you can see that it doesn't change the actual image size. It's still over 1 megabyte, and I don't even need an image with that resolution. This means I'm using a tremendous amount of bandwidth unnecessarily. We can save ourselves a lot of bandwidth and decrease loading time by resizing the actual image, so that we're delivering only the necessary size. Add the C-scale parameter to Cloudinary image to resize the image to a desired width, like 600 pixels. Now in DevTools, notice the reduced file size from around 1 megabyte to 25.8 kilobytes. What if you need your images to fit into a specific aspect ratio? Instead of just resizing, you can crop the images as well. To do that, first change the method from crop equals scale to crop equals crop. Then define the height and width for a square image, for example 2000 by 2000 pixels. Now let's see how that looks delivered using HTML. It's okay, but it might be nice to make sure the focus is on the face. Use the automatic gravity parameter. Add gravity equals auto and let's see how the delivered image looks. Cool, now it looks great. Let's just deal with the image size now. Cropping that huge image around the face didn't reduce the size too much. The dimensions are still 2000 by 2000 pixels. Let's further scale down the cropped image to get it down to an efficient size by adding a chain transformation. Add the crop equals scale method and specify a width of 600, making the same picture even smaller. Now let's double check the size of this image using DevTools. Great! By chaining resize methods, you gain flexibility and control over your transformations, because different combinations of crop and resize produce different results. Let's take a look at the image we just generated. We cropped it to 2000 by 2000 pixels, then scaled it down to 600. This gave us a close-up of a specific area in the image. If you want to zoom the image in or out, you can crop around a bigger or smaller chunk of the original image. For example, to get more of the image within your crop, you can crop the width and height to 3000 by 3000 pixels, then scale the image down to an efficient size. Check out the zooms out result. Alternatively, you can use crop equals auto and crop it directly to 600 by 600 pixels. In that case, AI automatically determines the best crop based on the gravity and specified dimensions. Let's see how that looks. In this case, Cloudinary gave me the entire figure of the woman with a little padding around. And finally, you can use C-fill, which automatically scales the image down to fit the specified dimensions and crops the longer size to fit. This is the result. Next up, learn how to upload images in Python.